Well, hey guys, good evening. It is John C. Morley here, serial entrepreneur. You're tuned into Inspirations for Your Life. Great to be with you. If this is your very first time with me, I want to take the opportunity to say welcome and I want to say thank you for joining me. If you've been here one time, 5 times, 100 times, or many times, more than that, I want to say thank you, but I also want to say the words welcome back. I always appreciate people that enjoy the quality content that I produce here on the show. So if you guys are thirsty, I just finished having something to eat, and I have a delicious RO water bottle here with just a hint of natural lemon, which is really very refreshing. All right, guys. If you're thirsty, feel free to go grab yourself something or hungry or whatnot. Feel free to go grab that and come on back. Don't forget to check out believemeachieve.com for more of my amazing, of course, inspiring creations, which you can do 24 hours a day. Not now, but once the show is over. All right, guys, let's kick this off. All right. So today, ladies and gentlemen, if you're watching us live, it is May 14th. It's a Thursday, 2026. And it is great to be with you. All right, let's kick it off. This is Inspirations for Your Life, in case you're wondering. And so our master topic, ladies and gentlemen, for the week is a very interesting one that I think doesn't need any special recognition for, but I think it's important to talk about, and that is how people adjust when life shifts without them being aware of it, right? So this is Inspirations for Your Life. I am John C. Morley, serial entrepreneur. I'm an engineer, marketing specialist, video producer, podcast host, coach, keynote speaker, graduate student, and a passionate lifelong learner. And I'm now very grateful to be a published author. Just released my book last month, Drained to Driven. All right, guys. So let's just get right into this. So a big welcome to everyone to the show, if I didn't welcome you enough. Today, I'm exploring how performance behaves under pressure, right? Not in theory, but in real operational environments that we're in every day, where inputs increase, time compresses, and execution still, has to remain stable. And I think that's hard for a lot of people is, how do you remain stable when, like the sky is falling or everything else around you is, suddenly in a disarray. So that's the key. When you have all this stuff happening, you still have to keep it together, right? So this is where systems are tested, not by calm conditions, but by intensity. The goal of this episode is to understand what holds, what breaks, and what stays consistent in your life when pressure becomes the default state. That's our key. So let's break it down. All right, everyone? Let's break this down together. First part, performance under pressure. Okay, it begins. Execution remains stable under pressure. That is the key thing. You do not change your output when there's pressure. Number two, attention holds during high input conditions. Attention holds. You are cognizant of what's going on. You're present. You're in the moment. Number three, workflow resists interruption cycles. Number four, task execution remains structured. I said this before, guys. To be successful, you have to be consistent and you have to be structured. Number five, you ready for number five? Number five is cognitive load remains balanced. Yes. Number six, output remains consistent under demand, right? So when you've got a lot of tasks, you have to know how to balance these tasks. If you don't, well, that could be a big problem for you and it could get you stressed and also get you into a panic and then not delivering at the highest level and possibly making lots of mistakes. Number seven, guys, decision-making stays clear under pressure. I think that's hard for a lot of people to realize that we have to keep the decision clear under pressure. And when we can do that, then things become easier for us, right? They become easier because we're no longer fretting about the pressure about what's going on. We're not fretting about that. Number eight, focus remains stable in complex environments. That's not an easy thing to do, guys. When things kick up a few notches, as Emma would say, And that kicking up actually causes some stress, unfortunately. Number 9, productivity remains controlled under stress. So our output remains controlled and our productivity remains controlled. By doing that, our throughput, the number of units being pushed through, stays constant. If suddenly we had a bottleneck because we got stressed or there was a problem, we'd have an issue. The other day, I was at a presentation, and I always get there early. I was having lunch, and then I got up to the speaker area, the panel, and I wasn't the first one speaking, but I got my laptop all plugged in and everything. And I noticed there's no power. So I motioned to the MC. I said, "No power." He said, "Did you check your plug in the back?" "Yeah, I checked all that." They checked the plug in the wall, checked the laptop. I said, "The plug doesn't have power." "Oh, we got to get that." So we just extension cord. And within a few minutes, somebody showed up with an extension cord, didn't disrupt anybody else. They plugged it in. It's like, we're good. And so if you were to fret or you were to worry about that, then that could have made a very, let's say, minorly challenging situation become overly stressful and could have even ruined the presentation. Okay. So that's important to know. Number 10, guys, input filtering remains active. So a lot of people don't understand why we have to keep things active. And I think the reason is that it's our wall, right? Think of it like a firewall, for example, right? The firewall always has to remain active. If things get more threatening, the firewall has to lock down more dynamically. But in our lives, when a situation comes that, let's say, challenges us or puts us to the flame because, we have a situation that we weren't prepared for, hopefully we were proactive and we thought about potential things like, extension cord, stuff like that. Now, if it was my talk that I was doing solely myself, I would have had extra gear on me. But because I was a guest of a panel, it wasn't my whole show. And so that meant it was different. And so somebody else was responsible for the audio, the video, and that kind of stuff. The only thing I had to bring was my laptop. Number 10, input filtering remains active. And so when we know that, we don't get stressed about it. At this stage, guys, the difference is not effort anymore. Nope. It's the stability of the structure under the load for which you're operating. I know that's a lot but in English, what that means is our stress is predicated by the number of people, objects, situations, and challenges that are pulling us at that same given moment. Controlled operation under a load. The one I like to think about is an APC unit, where the operation has to stay controlled under the load. As long as you operate within the parameters of the electrical specifications, you're fine. If you go under that, you're also fine. But if you go over that, well, that could be a problem. It could cause your system to drop out. It could even, in some cases, cause a fire. So load is very important to understand the load. Number 11, guys, workflow remains organized. And I think that's hard for some people. How do you stay organized when the ceiling and the floor are suddenly, coming apart? When your world is starting to shatter? How do you make sense of that? Number 12, guys, attention recovery remains fast. We want to be glued like a laser beam to everything going on so that we can respond reactively if we need to. Hopefully we don't, but if we need to, we have to be right like a pin or a laser beam. Number 14, execution timing remains predictable, which goes down to things like throughput. We know the number of cars going through a car wash and things like that. And when we know the cycle and we know how long something takes, if something takes a little longer, like, well, wait a minute, what happened? Maybe we built in the formula that the car wash does X cars an hour. Now, let me see if I can try to explain this to you in a real world example. So how many cars, let's just say, does a car wash, let's say, do per hour? How many cars do you think they do an hour? So car washes typically can handle between 10 and 150 plus cars per hour, depending on their setup, depending on the type of system that they've installed. Modern high-volume express tunnels wash often processes over 100 cars, as I said, per hour, while the smaller in-bay automatic rollover systems can handle 10 to 60 cars per hour. So a lot of the ones you're seeing now are the tunnels, the tunnel wash systems. And the express tunnels, these use conveyor belts to move multiple cars through at once with high performance, sometimes exceeding 200 cars per hour. Flex wash, you might have heard of, it's only 20 to 100 cars per hour, depending on the staff and the service complexity. There's IBA, in-bay automatic, and mini tunnel, which is 35 to 60 cars per hour. And the rollover drive-through is 10 to 60 cars per hour. And the hand wash, well, that's just under 4 cars per hour. So the key factors affecting the speed, okay, call them our variables, the equipment. The tunnel system with conveyors allow for continuous washing, whereas rollover systems require cleaning 1 car at a time. Staffing and operations, increased staffing and high speed and dual belt conveyors maximize efficiency, allowing some slides to handle over, let's say, 1,000 cars in a day. Weather, rainy days significantly reduce the traffic, potentially dropping it to 0. While sunny days following bad weather lead to a high demand. So that's known, ladies and gentlemen, as our throughput. And as long as we have our system, let's say we know that our car wash does 120 cars an hour, okay? But we know that we want to figure for a potential flaw. A car not getting on a track right, or a machine, something getting stalled. So we're going to say our wash does 100 cars an hour, and we're still safe because on the average amount of time, we're probably doing about 118, 119 cars per hour, even though it's 120. Pretty good. So when we have a system and we know the system and we work it, we're able to have predictability, right? We also call that science, right? When we have a method and we do it over and over again. In your life, you have an algorithm. You get up, you do certain things, you're going to have a certain result, right? I think that's an important thing to understand. The execution timing remains predictable. And when it remains predictable, people are not stressed, okay? Number 15, cognitive structure remains intact. Your brain remains intact. You're not stressing over the cars going through because there's a system in place to handle the cars. Systems. Systems can be big. They can be small. But the most important thing about a system is it could take a process that needs to be done over and over again and do it right. Sometimes when humans do the process over and over again, they can make mistakes. That's often what happens. Number 16, guys, output systems remain stable. Like with a car wash, we're going to get 118, 120 an hour, right? So you're figuring that the system can do 120, 125 an hour, but you know safely you're going to get 118 an hour because maybe something goes wrong. There could be a belt issue. Maybe a car doesn't catch the track the first time, so maybe we have to wait. So there's things like that. And we're still above, the expectations that we set. We're still higher than the throughput that we said we're going to get. Number 17, guys. Workflow remains controlled. So we know that if our car wash can handle, let's say, 100 cars an hour. Let's just kind of think about this, right? So how many 100 cars an hour? How many cars can enter, let's just say per hour, how many cars can be in the tunnel at one time? So if we're doing basically a car wash, okay, it does 100 cars, okay, 100 cars an hour, per hour. How many cars can be in the tunnel at one time? Pretty simple math question, right? Typically processed between 40 and 100 cars per hour. 100 car per hour rate usually requires a 24-minute, approximately 80 to 100 plus foot tunnel, often with 3 to 6 feet of spacing between vehicles, allowing for 3 to 5 vehicles to be washed simultaneously in the tunnel at once. And they move through the tunnel very, very quickly. But I remember looking at car wash tunnels when I was younger and how they would take a long time because the technology just wasn't there. All right. Number 18, decision cycles remain structured. So the logic, if the car has, let's say, white walls, the sensor is going to pick up the white walls and it's not going to spray the tires. Okay. Number 20, task flow remains stable. So what do I mean by that? We mean that the process is actually consistent and it's working just about every single time. That's the important thing. When we have a system and we use the system, we work the system, we get good output. This, ladies and gentlemen, is where performance shifts from reactive to controlled execution, or what I like to say, proactive. Well, so in a car wash, you can't really be proactive, but you can be controlled. And being controlled is similar to being proactive because you've planned in advance for potential pitfalls that could eat away, your production washing time. Consistency in demand environments. Productivity remains consistent. I think that's an important one to understand. Productivity must remain consistent. If it doesn't remain consistent, then we have a very, very big problem. Okay? A very, very big problem. That's an important thing to understand. Okay? Very important thing to understand. I think more people can realize that. But I think we have to know our system well. And then we have to put trust in the system. And then we have to train other people to make sure they use the system. Okay. Number 22. Input overload remains managed. So what happens if you try to put more cars in the car wash? Well, first of all, you're not going to be able to. But if you try to put too many in the car wash and something happens, so let's say there's no 3-foot gap and now there's only a foot gap, now we might have issues where the car production or washing is going to need to stop or slow down because the car, let's say, in front of it is not yet finished. So we're taking into play all these little anomalies. Number 23, guys, attention remains regulated. When you use a system, your attention doesn't skywall all over the place. It stays in one lane. Systems really help us de-stress. They take care of the monotonous, repeatable tasks over and over again, and we don't have to worry about them. Number 24, execution remains reliable when we use a system and we know how to work the system, right? I'll give you an example. So my mom owned a dry clean plant for many years. And we had something called the day system where you take the ticket and you'd basically pin it or staple it to the person's garment, but we'd always staple ticket to ticket. We would never, ever staple ticket to garment or even label. The worst case would be label if we couldn't get it. But we would take the ticket and we would literally, around the man's belt, we would put it around and we would like take two and make it tight, and that would stay just like that. Now, in the case of it could be a skirt or something and there's no place to put the ticket, we would use a pin. On a suit, there would be a hook on a lot of good suits. We'd put the ticket in the back and we'd go two things quick. And we'd make it tight so that the staple is right there so that it would really hold there. Understanding that system was not hard, but if you didn't know how to work the system, that was one thing. So what we decided to do, ladies and gentlemen, we decided to do this a while ago. We decided to switch over. My parents sold a long time ago. We decided that what you needed to do was need to switch to the lot system, which, to be honest, seemed very, very complicated. Okay, but you had to learn that everything was done in 100 pieces, and you didn't move to the next lot until these 100 pieces were done. So it was pretty straightforward, but you had to understand how it worked, and you couldn't go running another lot until this one was done, or it could become a mess, right? Number 27, performance remains stable. And if we know that, we trust the system, it'll work. Okay. Number 28, control remains active. Active. Not just today, not just tomorrow, but it remains active all the time. And all the staff members need to be trained on that system. That's probably one of the biggest things that I can tell you. All right. Number 29, systems remain functional. So, one of the best analogies I can give you is your air conditioning. Okay, without getting too technical about it. Let's say it's hot and your air conditioning doesn't work. It's vital that that system remains operational and functional, or you're not going to be too happy sitting inside at 100 or 120 degrees. Right? That's not going to be very, very pleasant. So, a system, first of all, you have to know the system, but you have to make sure that the system runs over and over and over again. I think that is one of the biggest things that I can actually tell you. Okay, you have to do that over and over and over again. All right. If you don't, then you might be unhappy. Okay. You might be unhappy because you're doing something that's not in alignment with the way the system was designed or the way it was built. How many times have you ever heard somebody say to you, that's not what it was designed, that's not what it was used for, that's what it was designed for? You can use it that way, but it's probably going to break because it wasn't designed to handle that kind of stress from that angle or what have you. And people look at you like you're funny, but seriously, a system is designed to perform something. If we try to make something be something else and it can't support it, not only are we going to foul up the system, we're probably going to break the hardware or whatever is being used to make the system. And in our case, for the lot system, so the way it worked was when it was the lot system, you had 1 to 100. Okay, I think it was one. It was 1 to it was 1 to 100, or actually, was it 1 to 100? No, it wasn't 100. It was actually I think it was 0 to 99. It was 0 to 99. And when we took the clothes in on the register, it printed out the lot tags immediately for us. So they would be thrown in the bag, they go in the back, and then we would basically have the tags and they would all be ready to go. The only problem was if somebody at the register didn't count the clothes properly, like they rushed and maybe, or the person, the lady or the gentleman, the register was rushing them, but that doesn't really make excuses. They shouldn't have let them rush them. And when that happened, you know what happens? I'll tell you what happens. The count is wrong. Instead of it being, let's say, a count piece of 24, now maybe it's a 26, okay? Or maybe it's a 25. How would that happen? So you could miss an item, but a lot of times what would happen is when you get a suit, you wouldn't check if it's a 2-piece or a 3-piece. And then what we'd have to do usually is call the customer and say, now, one thing, if it was less, that was easy. But if we put more than what was there, now they're going to say we lost the garment. So you got to be pretty careful on how that works. And so another way that would happen was with the shirts. We would always count them by colors, but some of the kids there would just count them quickly and they would not separate them one by one. And 42 shirts, not 41 shirts, because people were rushing. When you use the system that we put in place, it worked for you. It really did. So high pressure control is achieved. We achieve the high pressure and we get the maximum results. So this is the point where systems stop reacting and they start sustaining output under pressure, right? Think about your air conditioning system, right? What it has to do. Now, when the system works and it's calibrated correctly, it works, right? But if it's 120 degrees outside and it's only designed to keep you, let's say, 20 or 30 degrees cooler inside, then the system's not going to work so well. It's never going to shut off. That's a problem. What does this really mean, folks? What we are really observing here is not strength under pressure. Nope. It is structure under pressure. Not strength, but structure. Because pressure does not create failure. Nope, it doesn't. It reveals instability that was already present. Let me give you an example. I had a client of mine that basically brought a printer in for repair. And they actually damaged the liquid crystal display screen. They also had another problem with the printer. The printer had a bad fuser. So that was easy to change, but we couldn't reset the counter on the fuser because the screen where we went to program, well, it didn't work. So what happened was when I got the printer, I noticed it was all shattered. I literally didn't even touch hard. I just touched the corner very lightly, and it cracked. Now, I didn't cause that, but because of the stress, okay, from the way it was handled, it eventually broke. So it's not about the pressure. It's about the structure. When systems are structured, pressure does not break them. Let me say that again. When systems are structured, pressure does not break them. It tests their limits, right? A lot of times you might say, gee, this chair is weighted for 100 pounds, 200 pounds. I remember I was looking at a tripod the other day for something. And it says, oh, well, it's enough for an elephant to sit on as long as the elephant is 33 pounds or less. I don't know about you, but I don't know any elephants that are 33 pounds. All right. So the average weight of an elephant, if I had to guess, it's 13,000 pounds, 2.5 to 7 tons. That's a lot. So how many pounds in a ton? That's probably a useful thing to know. 2,000 pounds is 1 ton. 1 ton. So why most performance fails? It's right here. Most breakdowns do not happen because people lack the skill. They happen because an attention becomes fragmented under a load. When attention splits, everything downstream becomes unstable. Decisions slow down. Execution becomes inconsistent. Output loses structure. Workflow becomes reactive. We don't want that. It is not effort that fails, guys. It's attention organization. Yeah. And what stays stable when structure is strong? Certain things remain consistent even under pressure. Decision clarity, execution, rhythm, output, reliability, focus, stability, task organization. These are not emotional traits, guys. They are system outcomes. Yeah. That's important, guys. The practical takeaway for today, high performance under pressure is not about pushing harder. It's about reducing fragmentation while demand escalates or increases. When input is filtered and attention is stable, execution remains consistent in complex conditions. Ladies and gentlemen, I'm John C. Morley, serial entrepreneur. Be sure to check out BelieveMeAchieve.com for more of my amazing, inspiring creations. And we'll see you on another show real soon. And remember, guys, pressure does not define performance. Structure does. Be well, everyone.